Mhm. Mhm. I think it's live, right? I will check for the voice if it's good enough. Hello, hello, hello. I will check for the voice. So the voice is really good, like everything good. Firstly, thanks for waiting, and I apologize that I 2 hours late because of certain uh, uh emergency. I have to step out of the house, I'm sorry that I was not able to be here. So let's quickly start with today. So what we're gonna do today is revision because right now we have done the 7 days of studies. Now it's time to recap everything. In case you are here for the first time, make sure you subscribe our channel because most of the link and the live session uh create and post we keep here, and we always try to come at 12 p.m. GMT time here. So I always keep on updated by the post, so don't worry about that one. First of all, you can go to the LinkedIn to follow me because most of the articles that I don't release here, I keep it there. Good to get because that's very important. You can simply select this thing. So you are here, go to the number 4 directly, SQL 02 here. So this is something we have covered in the last 14 days, but it was supposed to be done in 7 days. It got extended beyond my imagination. So I have to wrap things early going forward and be on time. So what we gonna do today is we're gonna recap everything from this to this. Okay, so it's gonna be revision and a practice. And then for tomorrow, we're gonna start with the week two query. This was supposed to start at 8, but right now it's 12, so we are delayed by 1, 2, 3, 4, 5 days. Okay, so okay, so that's my bad. Okay, let's get started with one. So in next 1.5 hour, we will do everything that we learn from here to here as it is. Okay. Second thing, in case you missed out the recording or something, you can simply go to the live sessions. Okay, and in the live session, all the sessions are available with the proper description, what we are doing, what we are not doing in the video. So that's gonna be something useful for you. In case you don't want, if you don't want to like get into here and you feel like, okay, this is not something I can follow, I can't simply watch 2.5 hour or 2 hours of video just to understand a few things. Few of the things are repetitive, so don't worry about this one. Then simply come to the short. Here I have created the short videos, and in case you don't want to you want to just have a proper summary of the live session that we have performed here, you can simply go to the videos, and in the video we have already uploaded the corresponding summary of that live session into very crisp video, and it is something we use through and through. So all the information that you're gonna get there, it is highly uh, specified into this one. So it will be very useful for you. Can simply go and check. So it's just like a 5 6 minutes. I make sure that it's never exceeded more than like 7.5. So within the 7 minute, you can like get all the information that I am delivering as part of this thing. Okay, that's one thing. And if you are the guy of the short video, you can simply go and watch this one. So yeah, my shorts are doing pretty good, like 45 views, 32 views, 17 views, 88 3. So I'm also good, but subscribers are only 2. So yeah, please make sure you subscribe. So let's get started with the revision. So on the first day, we started what is SQL, what is database, what is relational database management system. But I am going to curate this thing into very interesting thing. For furthermore, I am using Pomodoro so that I keep myself aligned with the timeline. Okay, so for the first 20 minutes or 25 minutes, I'm going to do this too. Okay, and then remaining, then the next 30 minutes, I'm going to talk about this too, and the last 30 minutes, I'm going to talk about this thing. With this, we will be in sync. So let us start it with the first two. So the second one, if I talk about the MySQL Postgres installment, what you have to do, you have to go there, uh, their official website. You can simply type PostgreSQL downloads. Okay, if you write this one, the very first website gonna come is this one. Simply click here. Here you can simply choose this one. You can simply have to see that this one is a link. Download the installer. It's not the things. Dude, what happened? Why? Okay, so so I will just repeat that one. You to download this one, you need to type here PostgreSQL download. You will get this link. Click on this one. Check or pick the operating system your computer or your machine is working on. Okay, and don't scroll down because that's information. This is the first thing they have provided the link. And last time when I was scrolling, I just passed by it without realizing that it's a link, not a just text. So just click there, and you can simply click or download whatever is as per the according of your uh, operating system. For me, it was Windows 11, 64 bit, like 64, and simply download and you can install it. Okay. One caveat: when you install it, it will give you four and five option. One option that you have to deselect is the builder. You don't need a builder apart from this one: PG admin, PG server, and PG CLI. These three things you need it because PG server gonna act as a host of your database, your table, your schema. So it's gonna is person who's gonna maintain and operate your relational database management system. PG admin is your interface that help you connect to this server. Okay, and why I'm telling you, I will tell you the architecture that then you will understand. Okay, it will help you to connect with your server or the server who is responsible to maintain set up and maintain your relation database management system. And this connection is formed through CLI, that is client server mechanism, and that's unit. So what happened with the this disconnecting and reconnecting? I think there's a problem with my network. Okay, so guys, I was just checking. There's a problem with my network and it's working back fine. So let's get back to here. So we discuss how to install our Postgres SQL database management system. So we are good. We can simply we are done with the second thing. Now we need to go and understand the overall architecture and the common terminologies that we're gonna repeatedly use in our tutorials going forward, right? So I will start here. Okay, so let's make it big because everyone love big. Be it money, be it house, right? Don't get me wrong, dude. Okay, so let's just start. Sorry, guys, I'm drinking a bit of my beverage in between. Please don't. Okay, day four revision. So we are done with the installation part. Okay, in case you still need help, there's a lot of videos available online. You can simply go and refer one of those. It's very simple and quick to do. Now we will start the first thing that we need to cover in this particular session out of three sessions. Right now we have three sessions of 30 minutes each. We're 25 minutes, we're gonna talk, 5 minutes for rest or regenerate or any questions that we need to take. Okay. So in the first session, we're gonna cover installation is done. Then we're gonna talk about the terms and terminologies that will be widely used going forward and the understanding. The very first thing that you gonna interact is RDBMS. The second one that you gonna talk about is a database. The third that you're gonna talk about is a schema, SHMA schema. The fourth one that you're gonna talk about or you will frequently talk, I think this is the most important one, is tables. And the last one that you're gonna talk about is your SQL. Okay. So we gonna so we're gonna like in direction, but we're gonna start with the very basic and foundational thing, that is SQL. Okay, then we will go pace back because you need to start with the foundation itself. So what is SQL? Okay, SQL stand for structured query and language. Okay, and each of this word have or represent the features, the very critical salient features of this whole architecture. Okay, so before I move and start explaining what is SQL, I need to give you a scenario to understand why we are actually studying all this one. Because until unless you are really, really clear on this one, why it came into existence, you won't understand its significance and you won't be able to consult people about its greatness or its salient feature. That's more. So initially, what happened when we started our journey as commercialization, people were using papers, notebook, everything to keep a track of the things, right? And these are the things, for example, the person who is working in the shop, they were using this thing to keep a track of people name, okay, name, then their address, the date of purchase, then the items of purchase and the corresponding shopping on which date. So for a very small number of this kind of a data where you have information about something in a row and column manner, it becomes tedious as the size grew. And that's where the application like Tally or Excel came into it. Excel, what it does, it let you document everything in there, everything row and columns, right? Every column like this is the foundation of an Excel. Right? And what it make things better than the paper was, it was easy to access. Okay, easy to access. Second one is easy to find. You can easily find even if you put like 1,000, 10,000, 1,000,000 file, and you can simply press Control F and find the particular item or particular person. And if somebody is ready for that, highly accessible and highly easy to search that. Second, it become very and highly easy to search that. Second, it become very easy to apply formulas. So what formula does, when you write a small syntax or small command, you can get a lot of meaningful information. For example, suppose this column, this column is total price that a customer paid. Like customer A came, his name is something A, address is something A dash. He purchased suppose three item and the total cost was $100. Then B came, B is the name, then is the address B dash. He purchased one item for $10. Then C came and so on. So what you can do, you can simply here in this shell, you can write equals sum of all the item for the column, right? Excel started to make your life easier and started providing more features. Okay. But the problem started coming when the complexity increased. First, you want more than just sum or average, you want to go beyond that. Second, you want to add up or get multiple source data. So for example, one in one Excel or one sheet you have customer data, in second Excel you have ordered data or a sheet, okay, right? And now you want to come all this in the sheet of sales, right? So now to perform this one, you need to do a lot of for to pass this one, then do this one. Link and stuff. So just give me a sec, buddy. I'm just getting a call. Hello? या बढ़िया भाजी बता. हाँ दोनों तरफ की आने जाने की. मैं आपको बाहर शाम को भेज दूँ, अब थोड़ा बिजी है भाजी, थोड़ा सा. ओके. जी 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 जी. I'm sorry guys, I've talked about the emergency, right? So that was the emergency. So I paid from my pocket. So I need to send that's in between. Okay. So now we have three sheets you need to add up into a single sheet, right? So you need to add so many formulas, and just to make this, it will consume a lot of time for you. All right. So that's one thing. After this, you as we perform the sum and average, you need to perform sum and average for two columns, then three columns of combination for a particular case. So the more you started doing here, like here, what gonna happen, it will increase the cost and time for this formula to execute. Why? Because the data you're bringing here, you're bringing through formulas from this places. Why? Because if you just copy paste, okay, suppose you have copy pasted and then you apply formula, okay, it is taking suppose 2 seconds, perfect. But what happen if the new information came in? That means you need to replicate this again and again, and that's not a right thing to do, because there is a linkage. For example, there's a product A and it got sold to three different people, P1A, person 2A, person 3A, and the detail of A uh, person and the item is O1, O2, okay. So this O1, O2, 3 details are here. That means you need to do a linkage before you create this sheet. That's something you have to do manually in case you are going for copy and paste. It is increasing your time, effort, and manual things. So that's something we don't want. That means you're going to use the formula. Now, if you use the formula, the time is going to consume to refresh this data at given point of time. It's going to say, suppose 10 seconds as the size keep on increasing. Then on top of it, you're going to apply this formula. That means it's gonna increase the time, total time gonna increase to from 2 seconds to suppose 20 seconds. This is a simple example. There are examples where same sheet, a single sheet is being linked through multiple, like more than five and six one. That means the more the complex data, the complex system you are trying to develop using this paradigm, it become hard. Literally become hard for Excel to perform well. And that's where using the same model people created people created relational database management system, where they started using database for storage and organization, and structure query language to communicate to this database through this relational database management system, and started giving us the results, uh, the result we want from these formulas. And it is so easy that you will feel like, oh my god, why it was not invented earlier. And the best thing to support is, for the last 50 decade, I'm sorry, for the last 5 decades, 50 years, this was in industry and is still being used by most of the companies around the globe. So you can imagine the power of relational database management system, that even after 50 years of its invention, it is still being used. Okay. So I think we are very clear, like why we need this and how it came into picture, right? So let's quickly start with SQL, right? So it's called structure query language. I told you this enables you to talk and get meaningful information from tabular data in a relational database management system or in a database. Okay, so this is a language that help you. So SQL is a language that you use to communicate to the table or the tabular data stored inside a database. And who enables you to do this is relational database management system. Got it? So this is simple. So structure query language is structured because it operate on tabular data. That's why it's a structure, because it can only talk to a tabular data. That's also stored in a database and is being communicated through relational database management system. Q for query. So what happened when we talk to this one, we tell the command, we tell them that what we need from this data, and this relation database management system take care of that one. For example, there is that patient information, right? Suppose there's a table of product. It have the product ID, product name, product quantity in inventory, and etc, right? I ask him that, can you send me the product IDs where the quantity is zero? That means you need to replenish those products, right? So you simply ask them that, give me the records of the products who have quantity 0. So it will take this query, it will go inside this table, execute it, and get the data for us here in the form of table again. So that's why this talk of like giving command and getting the values, or giving the query and getting a result. That's why this language is called querying language. Now I'll again stand for language. Here means it's a declarative language. I told you that we are using the query to communicate. Like we send a query, we get a result. We send a query, we get a result. So it's a declarative. You tell them what you want. You never tell this relational database management system how to do it, because this is so responsible for doing it, and that's why it's the best example of abstraction. I don't tell him to go and connect this one to and start reading, then do everything. No, I just tell him that what is my query and he'll take care of that one. That's why it's a query language. Perfect. Okay. So in a language, there are two important things. When you learn a language, what you learn the words vocabulary. Second thing, you learn the grammar, how you integrate these words in a meaningful sentence, right? Similarly, for SQL, words are keywords like select, from, update, delete, etc. And the grammar is the syntax, how you gonna use the syntax, a format to make a meaningful sentence that goes to relational database management system, get that query done, and give you the result. Okay, so that's language we're gonna learn as we go forward. So we are clear with SQL, we are clear with the table, okay? But for table, I will just repeat it, table. So any information that can be stored in tabular format, that means row and column, right? A row in this particular system of relational database system, it represents one entity, E1. This is gonna represent entity 2. This is gonna represent entity 3. And the column gonna represent the corresponding detail about that entity, about the entity, or you can say it tell about the characteristic, or one characteristic of that entity. I will give you a very good example. Suppose I want to store people. Yes, no, no. I want to, so to make it very simple, let's suppose I want to store information about a group of students, a group of student, okay, students, a group of students. I want to store their information, okay. Suppose there are three people, students, one, two, three, A1, A2, and A3. Okay, I want to store their information. What I can do, I can ask information for this guy. What's your name? A1. What's your student ID? One. And what's your address? You can say ADD1. I went to A2. I asked him, what's your name? Is A2. What's your student ID? A2. What is your address? ADD2. I went to third student. He gave me A3's name. Three's role is ID, and then address is ADD3. So now I have information like this, and I get to know that what is common. Firstly, they are similar entities, right? What similar? Okay, this is down. I have 4 minutes to just. Okay. So these are similar. Second thing, all this have the same details that I want to store, or same characteristics that I want to store. Okay. That means I can use tabular structure. I will write the name, then the student ID, and then the address. It will be A1, 1, and ADD1, A2, 2, ADD2, and A3, 3, and ADD3. See? And I know that there is one software that can store this information in a very efficient manner, so that tomorrow if I have to get some information out of it, like information like total number of students, the student who live in a street in New York, like country, something from the address I can get it, country. All this meaningful information I can get it very easily using SQL. Okay, so I got the answer that for storage I can use database, and for getting information SQL. Which software is gonna enable me is these software who help you, or who enable you to store tabular form of data where the records, these rows represent the similar entities and the column represent the same characteristic or detail about that entity, correct? So they're gonna store where? Using a software that is called relational database management system. And the best example of this one is MySQL, MSSQL, and the one we're gonna leverage or use is uh, PostgreSQL. This is the one we're gonna use, and for our future endeavors, and I already told you how to install this one. Okay, so relational database management system enables you to store the data in a database, and it enables you to communicate it through SQL, structure query language. We are good. So we are good with SQL. We are good with table. Okay. Now we need to delve into schema, then database, and then relation database management system. Okay. So now I told you relation database management system enables you to store the data in tabular form inside a database. It does that for you. And then it gives you a platform to communicate to such tabular form of data where you store similar kind of entities with the same characteristic through SQL, structure query language, right? So suppose this is your Postgre SQL relational database management system. So this is a man that does the work, okay? And it does the work. So what is database? Okay, database is the organization and management of tabular form of data, right? Or in a simple terms, a database is a building. Database is a building where you store tabular form of data. Tabular form of data inside a relational database management system. So it's a database. Okay. In this database, every floor is your every floor. This floors, this floor, this floor, this floor, this floor, this floor, this schema. So what is a schema? A schema is nothing but a segregation within a database. So two different tables can exist in a same database but in different flows or in different schema. So segregation increase. So it make the data more modular in a packaged so that the access that you want to give to someone to a uh, particular data sets will become easier. Okay. Why is important? Let me tell you. Suppose this relational database management system, this building is nothing but an office. Okay. Now, if I don't do the floor, everyone will sit in the same ground floor, right? Is it right way? It become overcrowded, and if you want to find an engineer or a security guard, or if you want to find a developer or HR or finance guy or sales guy in a same apartment, same buildings, everyone doing the same work, so much noise, so much congestion, so much hard to even find a single person, right? But if you create one more floor, here you put the security or reception, then here you put all the other guy. Now there is better in terms of now you can easily access the receptionist and the security in case emergency happen. Now you feel like okay, this floor I want to reserve it. Okay, this is all done. I need to very quick. Let's start this second session. So in this second one, you need to make sure you set like okay, here I'm going to put the place where we have a meeting. So it's a conference room. You put everyone here. Okay. And now you realize that I want HR department to be very separate. So you put an HR here. Okay. Then you put everyone here. Now it become less crowded compared to first, right? Then here you felt like no, I need to keep my coders here. So I can talk to them very easy. So you put the coder here and remaining here. And the remaining were nothing but your salesperson at the very top because they are the top people. Now, the first place when you kept everyone in a single place, and now with this segregation, which one is easier to understand and to access? I think the second one, right? Perfect. So you need to understand when you create database for the first time, it automatically create that ground floor that is called public. And on and over, you can create your own schemas for inside the database. So database, you can say schema is a blueprint of database. Ultimately, this schema, the collection of this schema is nothing but it is constituting or it is making the database, right? So schema is your blueprint of database. How you design your schema ultimately collectively make that database, right? That is. Now you're clear with the schema, you're clear with the database, you're clear with the schema. Now let's get back to your table. So inside each flow, let's I take that flow. This cabinets, separate cabinets. Okay. This cabinet that is store items is your table. Okay. Now let's open this cabinet. You pull this out and you open it, right? This one. Here was the knob and here was the knob. And since it is a cabinet, right? You know that each cabinet will have this segregation. Correct? And this so each cabinet you can see this is cabinet where you store the information. The best part is the number of cabinet the top floor will have, the same cabinet is something is gonna have on the second cabinet, shelf or third shelf and fourth shelf. Okay. So cabinet gonna be same, the number of cabinet it will be same for entire shelves. Then you can place the corresponding item to this one. So this representation become easier for you guys. That means tomorrow if you have to access this particular uh cabinet and you want to access this particular record or item, what you have to do, firstly you have to communicate or get into relational database management system. Using this one you need to come to this database. Using this database you need to come to its public floor. Inside the public floor you need to then get access to this table and then you need to get access to this particular item. So how we do that one, we do through something called you will write database name dot schema database is your building, and schema is your floor, and dot your table name that is your cabin your almeida or your cabinet, right? So your table, and then you can define the cabinet you want to access. I think with this we are very clear with all the items we have discussed. We so with this I can wrap the first 2 days what we learned so far. What is SQL, what is your database, what is table, what is a schema, what is your database, and everything, right? Any questions so far if somebody joined? Okay, so I'm the only one who's watching, so this is pretty good. We can simply move ahead. Now we will get into a create table, drop table. So it's a table manipulation, then your database data type, and then your insert and output. That is your data manipulation. So let's quickly start with the table manipulation. Okay. So we understood so far here that this is how the total overall structures look like. Okay. I'm not going much into it because that's something we have created, we have gone through in our previous session. So this is pretty cool. Now, what we have to do since this is everything we gonna construct because we send the query and the relation database base management system does that, right? That means we can ask him to create database for us. We can ask him to create a different flow from the public default schema, right? Public. We can ask him to create a flow or a schema for us in that database. Then we can ask him to create a table, and then we can ask him in that table how I'm going to keep the cabinet in the shelves, right? So we can ask him to do multiple things. So let's start with the very basic. That's creating a database. Okay, let's create a database university. Okay, then we will create a table for Inside the university, what we're gonna have, we will have university table. Okay. Then the second one that we're gonna do from this one is to have a student table. Okay. And right now, these are so university is a database, right? So it's like a database inside relation database management system, like RDBMS is the database DB that is university, and this is a public schema by default, right? But what we want to do, we want to create another specific floor university, right? You can simply use public because university database itself the schema, but I want to create a separate schema university. Okay. No, not university. Let's say college, because inside a university there can be multiple colleges, right? College. Now it makes sense. Public is for university, and the college will be the all the collection of the college that present there, or it's available, or that's is affiliated through use university. Then the first cabinet that I want to construct is college detail. Is so it's gonna store the information of the college. Then a second box or storage that I'm going to create is to hold items or the students' details. Okay, that's something I want to create. Let's start doing that. Let's go here. So this is how your PG admin gonna look like. So this is the university that's already created, but I'm going to drop this one. No, I will show you how to drop it. Cancel. Okay. So let's go to this one, create a query, and let's close everything else. So don't save. Okay, so this is the so what I have to do, I need to so right now through this I already connected to relational database management system server, and I'm going to send query in SQL format. Okay, to tell him that I want to drop any schema. I want to first create a database called university, but before that I want to drop the database if in case it exists. So I will like drop database if exists, and what the name university. Okay. If I have any kind of a database like this, just drop it. So what it says, university is being accessed by other users. Okay, so that means this university right now is being used. So I need to close this one. So disconnect from the server. Okay, disconnect. Now I'm not connected to this one. I will simply run the query. Okay, see, drop database. So it automatically goes there. All the connection with that database is severed. Okay, now it's severed. That means I can run my query because there is nothing that right now hold an instance of it, and it's gonna drop. So if I open this one, you see university is gone. Now this is gone. Now I'm going to create. So create database university. Okay. So I'm going to create a database called university. Okay. Inside a transact book, create a database. Can I refresh it? Okay, drop error cannot run inside a transactional block. Okay, so I need to create, create database. Okay, so I can use this way, but I don't want to use it. Let's. Can I create database? Uh, less again severe the connection. So disconnect from server. Disconnect. Create database university, and I will run it. Let's see. So this application has lost the connection. If the connection was idle, forcefully disconnect the application. So do you want a new session? Yeah. Drop database cannot exist in the transaction data. Okay, so I cannot run it here. But why? That's my question is. Okay, but basically you understood that we can do that. So let's connect this one. Okay, here I will click here. I will simply create and create database and we will simply write it. The database is name is University and I'm the owner is Postgres and because that's me as an admin and save it. Okay, so university is being created, right? So this is the database that is inside a relational database server, this one. And this particular one have a schema public, see, public. But that's something I don't want. I want to create a separate for the colleges where I'm going to hold the information of the college. So right now what I'm going to do, I can create a schema, but I want to show you how to create this thing. So I will run the query tool here. I will do one by one. The first thing we already done the create database and drop database, right? Now we're gonna start with is creating a floor or basically your schema. Create first we will drop in case there is one drop schema if exists and the schema name is college, right? Let's run it. So college does not exist. Schema, this is a notice, not your this one, and you can see the query has been successfully completed. Now we can create a schema and schema name is college, right? There's something you will learn, but not right now. Let's quickly run it. So schema is created successfully. Now, if right now you won't see this one because the schema is one, it's a GUI, it's a user interface. Until unless you refresh it again, it will go back and gather the information that's currently executed after this was initially fetched, right? So every time you run a query, you need to refresh it in case you want to see things being updated on the left side. Okay? Second one, now floor is constructed. Now I want to have the cabinet for a college, right? So I want to create cabinet for bus table. Okay. So what gonna do? First, I want to drop any cabinet, drop table if exists. And what is that particular cabinet that I want to drop? So drop table if exists, and that is college. Okay, let's run it. Okay, so query executed. That means in case there is any cabinet with a college name, okay, that cabinet with a tag of college is gonna drop. Now I will create one. Create cabinet, create table, then table name is college. Okay, so I told you when you look from the outside, okay, when you look from the outside, your cabinet gonna look like this, right? In a floor, your cabinet is like this right now. So it's an so when you open this one with this command, what gonna happen? It will have nothing. It's like a blank one. Nothing. Not even single thing. It's completely blank, like there's no shelving or something. What you do, you need to tell him that in this one, I am going, so there are gonna be multiple slabs, and each slab or shelf gonna hold multiple partition. First partition will hold the item of college ID, okay, or you can simply say ID. Then second cabinet gonna hold item for the college name. Okay, that's it. Two things. No third, no fourth. Two things. I'm not going for address. It's simple understanding. Okay. So now with this, what's gonna happen? It have a blueprint that tomorrow. So what happened? This is empty, right? So tomorrow you feel like okay, I need to store ID one and the name of the college is University of California, right? So this blueprint will give you one cabinet like this with partition. Here you will put item one and then item name that University of Carolina. And you will pick it up and store here at the bottom. I like this. Keep it here. If second came, you will again take a here these trays are there for you. And you take a tray like this, you put the item one, two, now, and the University of Southern Carolina, and then you put on top of this one, like you slide it, and you keep on filling this one. Okay, this how these things work, and is still here, right? So once this cabinet is created, you need to create these tables that will be empty. You keep on putting the object, and then you will slide inside this one, right? Let's quickly go back here. So now with our query, PGR, okay, with this one, and then we put brackets. Uh, with this query, you have created that empty cabinet, right? Now you need to create that tray, right? So for that tray, you need to give uh, two basic information. First one is the column name. So my first column name is ID, and what kind of item you're gonna place. For item, I say what kind of a nature, like is it a metal, is gonna be gold, is gonna be silver, what is it? So for us, ID is integer. It's gonna be number, right? Integer. And you always remember when you created that tree, it always empty, right? It's empty. Right? So for this one, you put default now. Okay. Then you put the name. Name is a collection of words, right? So you put text. Again, default means if nothing is there, that you are creating that cabinets, right? That tray for those cabinets, right? So null. So that means you have created this table and the corresponding tray with two particular partition. First one gonna hold integer with integer value. By default, it have nothing in it. On the name, you will put the text as an item into that cabinet, that partition tray. And initially it will be empty. You will simply pick it up and you can slide it into your cabinet, right? But you know that every tray, every cabinet and the corresponding tray for this one always will be empty, right? So by default, this is always comes with this one. So even if you don't write it, it means same. That means the tray will have two partition ID and name. ID will have integer and name will have text, and they are initially null or empty. Got it? Perfect. If I execute this one right now, what happened? You have already slide this in, right? And now you want to check it. That means you need to slide it back and see the things. So this sliding back and checking the things is done through select. And inside the select, what happened? Ultimately, who is doing this thing? Somebody else is doing that is relational database management system is doing it there. I can't say it. So I need to tell him when you slide this out tray from the cabinet, what kind of item and object or the detail or the item in that particular tray I want to see. I want to see ID. I want to see the name. From which cabinet or which floor from? Floor is because we are already connected to database, this one university, so I don't need to bother. I want this person to go to the college floor, then access the cabinet, which one, no, sorry, schema is college and table is also college, yeah. So I want it to go to the college floor, then access the college uh cabinet, okay. And using select statement, it says to go and then to draw that out, tray, and from each tray you get me the ID and name for me. Okay, you're giving this command, this is a query. Okay, so let's quickly run it. Okay, so what it says, ID college, uh I'm inside the university, right? Perfect. Schema created. Line number 12 have an issue. What it says ID and name is there. It's a college doesn't exist. Why? Because create table. I'm accessing the floor and this one. Let's change. Let's put this schema like university. It should be college, dude. College. Let's check if it is executing till here. Okay, so table is being created and I refresh this one, college. refresh, and the table college schema is there. Okay, I think I need to go to the floor and then execute this one. Okay, I got it. What happened? See, that's why I want to show you. Okay, now that's exactly why we need to put a proper naming. So what it says cannot find this in the floor college, cannot find the table college, right? So if you see here what command I wrote, I am creating floor. How am I dropping the table? I'm dropping table directly this college. But when you don't specify which floor, it will automatically take public. But have I ever created any table inside public? Yes, here. See, it again take it public by default. And what I'm trying to access, I'm trying to access a college cabinet inside the college floor. That's why there is an issue. So now what you have to do, either you change a name a bit so that you understand. Uh, I think, how can you write it? I can write it colleges. Now it makes sense. And I will have the college as the name of the cabinet. So now what it's gonna do, it will go and access the college's floor, then access the cabinet college. Right? Now I will do the same. Now I will run, it should give me the replies. And it does. So right now in the cabinet it is empty because I have created the tray, but I haven't put any tray inside this one. Now we will do that insertion. Okay. So right now what we are trying to do in this one, we are trying to create, drop and alter, right? So we are able to create, we are able to create database, we are able to create tables, everything's done, right? Now what we have to do, we have to do table manipulation, right? So now we have created two tables. First one is we are able to create the table college and the inside the colleges, this one, right? So we are good on this one. We are really good. Now what we have to do? What? Now what we have to do? We need to do manipulation. Third is table manipulation. Table manipulation. So what happened that you created the cabinet, you created that tray, but you find that tray is not good enough right now. You need to change the tray size so it can have or store more information related to that college, right? So let's do that. What I want to add the address to that particular college in the college cabinet. I want to store the information about the ID, then the college name and the address of that college, right? Address. So I will add one more partition in that tray, right? And how to do it? Using alter command. Whenever you want to change that tray structure, you need to use alter table as a command and go the rest of the things we can do it. So let's do it. So right now what I have to do, I want to add 3.1, add column. Okay, right now I'm changing the structure, add column then drop column. So I can write alter table is a combo. Table name, what is the table name? So that will I need to access that cabinet, right? Because I need to change into that cabinet structure and then the tray structure. So I need to access that cabinet. And how to access that cabinet? I need to go to that database. I'm already in that database. Okay, I'm a bit behind, but yeah, I can do that one. So now what I did, I am going to access what I'm going to access the floor and then particular cabinet. So alter table was the floor is the colleges and which cabinet college. What I want to do, I want to make one more tray partition so that when I slide it, I can store more information in that particular tray. So what I'm going to do, I'm going to write again a combo of two keywords, add column. Okay. Now I add the column. I need, since when I created the partition, I used this logic column and column name, right? I need to do the same. I added, what I added like I need to have one more partition and the partition will hold information about the college address. So address will be the name of that partition and what kind of object you're gonna store. It's gonna store object like text. Okay, and again, default will be null, right? If I execute this one, it should get me the mm, error. Cannot drop the schema. Okay, okay, perfect. This is something I want you guys to understand, right? So, what exactly I'm doing here? This is the one of the best topic here. One of the best thing you need to understand, and is very critical because it's a domino effect. That's why I didn't place it. If you remember, I said I need to put something here. So right now here, when I'm trying, so what I'm doing in the drop schema effects is I'm trying to demolish a floor, right? Complete floor. But inside the floor, there is already a cabinet called college. Okay, so when you try to destroy any floor, you don't have a right if there exists one cabinet because cabinet have their own right to exist. Okay. So if you want to give permission to relation database management system that you go and destroy this floor inside this database or inside this building, and you don't have to worry about whatever inside that floor exists so far, you simply destroy that as well. So to give that permission of destroying the floor and the items stored in that floor, the cabinet stored in that floor, you tell them cascade. Cascade is that permission. If you destroy the floor, you destroy all the cabinet inside this one. Now everything is fine. See? That's how the things work. And you need to understand this one. Even though they are inside this one, they have their own right until unless you give the permission to relation database management system to go and destroy the floor and the cabinet inside the floor, it won't be able to do it. It will throw error. Okay. Now see, it is created like this, but why I can't see a column address in this one? Why? Because I choose only ID and name. Right now, I'm not choosing all the columns. Okay, this is the example of what I want to tell you. This is a example of specific columns. Okay, with this logic, what gonna happen? You will miss out the column, the newly added column. So to rectify this one, you can write select. That will you are asking relation database management system to go and access all the trays inside the cabinet, right? From floor colleges, so you are asking him to go to the database university, then go to the floor colleges, then go to cabinet college, right? And select is to access the trays one by one and get me the information. What kind of information? Right now, earlier you were just taking the information of the items from two cabinet from each tray. Each tray is like entity, right? But right now you want whatever the partition is, whatever the object inside that one, just give it to me. So you put a star. Now run it. You see address came now. Is it good? So this is the first thing that happened, that by default you create one more addition to that tray, that is address. Right now what you want to do, you want to drop this column. Something happened and you feel like, no, I don't want this anymore. Let's drop it. 3.2. You drop the column. Same. If you're changing the structure of the table, you need to use the combination of combo of this to keep a alter table. Now you're already in the building, right? You need to give the detail about the floor and the cabinet you want to access. Floor is colleges. When you want to access the college, correct? And now in that tray for that corresponding cabinet, you want to destroy that partition. And so you will say drop column address, right? Now here we need to add something. Like how we were dropping the schema and then we ask for cascade. There is a specific case when you need to use cascade or some other function. When this is also hold some other information. How? I will tell you later. Okay, now see when I use the star, it's gone. Okay, let's put it back. So after dropping, I'm just executing it. So I want that back again. Okay, perfect. So far, I'm good. So initially, I created one floor and then I created a cabinet, a university, and then in future when I started adding, I just added one more column. Okay. Now what you have to do, you feel like, okay, the ID that so first one is this one column, right? What else I can do? Uh, structure column, then not null, then uh, constraint, not null, constraint, rename, data type. I don't remember. Just give me a sec. Let me quickly open one of. So what is that? Uh, add constraint, drop constraint. So column constraint, then data type, not null, and default, and then rename. Okay, okay. So now, so you remember that I put the default as null. That also is default thing, right? Suppose for an integer, I don't want it to be null. If there is a value or you put that tree, you need to make sure it never remain empty. Okay. So what you do, 3.3, you will add constraint. Okay. How you do it, you will be like alter table again. Floor is colleges and then college. You said add constraint. Okay. Now you have added a constraint and you will be like the column ID should not be empty. So it cannot be ID constraint is not null ID and ID not null. If that's the case, or I think yeah, it will fail. I know. Or it should be not null ID. Uh, add constraint. Uh, 1 second, dude. 1 second. Let's me quickly check on this one. What I so again we will go here. I am talking about the table manipulation because I forget something. Okay, column adding constraint. Okay, so if I go to adding constraint, what check add constraint? Okay, it's a check, not null. Uh, set, but I don't want not null. I want a constraint. Yep. I want a constraint. Adding a constraint. Perfect. So I was thinking like how to add a constraint, what kind of a constraint I can add. Okay, got it. So at given point of time, ID, for example, this ID cannot be less than zero. Okay, for what kind of integer value is? Integer value is 4-byte character. It can have from negative to positive. But can the ID of a college be negative or zero? Answer is no. That means whatever the tray I'm going to insert, it should have value of ID always greater than one. That I need to check before I slide this in, right? So I put a constraint that alter table colleges to college that go to this float, go to this one. Now add a constraint to the all the trays, right? That constraint that check check is a constraint. Check. What I want to check, I want to check. This is a functional constraint. Check ID should be greater than zero. And now what is add constraint? Check ID greater than error constraint, then constraint name ID. What is this one? Okay, I need to put the. That's why if you don't practice, you're gonna forget. Okay, so You need to give the constraint name as well. So you will be like check ID or university ID check. It says syntax error. Perfect. So, so when you try to put constraint, a condition that you have to check for all the tray at given point of time, you run like this: alter table college this one add constraint university ID check where ID is greater than 0, right? And in case you want to drop any ID, any check, any constraint you felt like, okay, this constraint is no more relevant with my cabinets or with my tray, let me drop it. So you again do the alter table colleges dot college drop constraint. What kind of a constraint? That's why this you need this name. Uni ID check. Again, it dropped it. Okay. Now, apart from this one, what else you can do? You have already added a column. You have dropped a column. You have added a constraint, and constraint is check. You can have multiple constraint. Okay. The other one that you want to have is default value. Removing a column is done. Dropping a cascade, adding a constraint is done, and constraint not null. Okay, not null. It's a set not null, and drop not null, drop and set that. Okay. And what else was the column default value? Set default, set not null, the set default. This one. And okay. So we have done so far. We have added the constraint and we dropped the constraint. Suppose now at given point of time, any given point of time, any, I don't want to have ID as null. For example, there is a university. We are going to put the tray with some university detail. Can that university have ID as empty in that tray? No, it cannot be empty. It has to be a value, right? The corresponding ID. So what I'm going to write that add not null. Not null. I told you that by default every tray partition is empty, but there are few partition inside that tray that you never want it to be empty. It has to be filled with the legit value. So you write it that alter table, go to the floor. You need to go to the floor colleges and you need to access the college cabinet and you need to alter that table or that cabinet and the tray, right? What you need to do, you need to add. Okay, you need to do is to put that constraint not null, right? And how to do it? I think is a column name set not null. I guess this is the one, right? Okay, so here the interesting part is earlier we were add column, add constraint, constraint. Right now these are at a structure level. Now you need to do at the data level. So here you have to do is like alter column. Okay, you're changing that particular cabinet information, that particular partition, right? The tray, right? So you said like inside that alter column, you name that ID as set not null. Okay, set not null, not null, set not null. Okay, now this ID cannot be empty. When you try to slide this tray, it cannot be empty. But you felt like, okay, after some time, you felt like, okay, you also put this for this name, alter address, okay, alter table, go to the floor colleges, then college cabinet. And what you have to do, you have to put the address as not null as well. Alter column address and you set to not null. Okay, you have done this one. Later you find it out that okay, this address can be null. Sometimes your college address is not properly registered, so you cannot simply add this one. So given point of time, you are like, okay, no, I can't put it as not null. That means the tray that you're selecting the partition address always have a value. At a given point of time, is possible that you don't want to put address object into that partition. You want to keep it empty. So you will be like drop not null. So again, what you have to do, you have to change the table. So alter table. For this one, you need to access the table. So you need to go to the floor colleges, then go to the cabinet college. Now what you have to do, is alter the column address drop not null or drop null. Drop null. Yeah, done. Now you can put the tray with the partition of address as empty. But for ID, you should have a value. Okay. So we are done with how many things? One, two, three, four, five, six. What else in the manipulation is left? Data type. Okay, data type. You can leave it for time being. Column name change. So it's nothing but alter table, table name, that rename column, then the column name ID to this one. So it's not a big deal. So I think for timing we can leave it. We're gonna talk about something more than this. Okay. So now we want to change something. We need to make primary key and unique key. Okay. So ID for timing, let's drop the ID as not null. We kept it null right here. ID is not null. I will drop this one as well. So let's drop this alter table colleges college alter column ID drop not null. Okay. So now the tray with the partition ID can have the value empty. Okay. Now what happens? See, for times to understand that a particular what is the information about a particular college, that means you need to give him some specialty. For example, every human being in a country can be identified easily with his passport ID or with his national ID, right? Either of them. Similarly, you can use a constraint on an ID or the partition that will ensure the value of the object you store in this one is unique to that particular tray, so that finding that tray become easier, or identifying that tray or entity become easier. Okay. So what we will do, we will use unique. Okay. So what it says, you put alter table, you go to the floor colleges, then you access the college, and then you do constraint addition. You add a condition is constraint, and then constraint, what exactly the constraint is nothing but university unique ID. You're making sure that the partition into the tray where you put the object ID is always unique to that tray. It identifies that tray uniquely or that entity. Okay. So what you do, you put the constraint unique and put on the ID column. Okay, we have put this one. Now let's start inserting the data. Okay, now we put as many rules there. Now we will put that is insert, and this one was 4.1. Uh, add constraint unique. Now we will insert. Okay, start inserting. So for this one, we have a keyword called insert into. Like how we have altered table to change that cabinet and the tray. Similarly, when we have put the value inside tray and then ask him to put that tray into the cabinet, we use this insert into where you need to access that cabinet, right? So you need to go to the flow colleges, that cabinet college. Now you need to put first into that tray and then this command will run to put it there, right? So you need to first specify the relation database management system, which particular partition in a tray you want to access and put it. So you need to tell him. You tell him that inside the partition, I'm going to fill the partition ID, and then I'm going to fill the partition name, and I'm not going to fill. Then I'm going to fill the partition address. Okay, and values is the one that tell you that in this partition you're gonna put this value. This is the logic. Okay, this partition in the tray you're gonna put this value, and this will tell you to insert that tray inside this cabinet. So what is ID? You put ID as 1, then the name you put University of California, and then the address you put as empty. Okay, and I told you when you put default, it automatically all the partition in the cabinet, partition in the tray is empty. So you put like default. Okay, and when you run this one, see one UC and empty. The tray that get into this one has a partition ID 1 with the partition name as UOC and then the partition address as null, that is empty. Okay, you put that tray. You be like, let me put one more, insert into colleges dot college, and similarly this one. So this part tells him that you have to access the partition ID, name, address, and put the values as this one. So I put 2, then University of Southern Carolina, and you put an address of South Carolina, and now run it. Okay, now you get the values, right? In this tray you fill all 3 cabinets, all 3 partition in that tray, and then you put that tray into that one. Now I told you that this particular one have the constraint that it should always have a unique value, right? Now let's do one thing. Let's repeat something. There's one more university in Southern Carolina. It is called Patrick. Patrick. And it's have the same address. And because of misunderstanding, University of Southern Carolina, and then hyphen Patrick. You just saw this one and you put the same ID as two. When you run it, it says that ID already exists too, so you cannot put it because that particular partition should always hold an object that is unique. It cannot be repeated, right? That means you need to put as 3. Perfect. You got the 3, now insert it. Now let's put more records. Okay, you will be like, now you put another information, but here you put null empty. You said like, I don't have the ID. Let me put it default. And what was default is was null, and you put the University of New York. Okay, and address you put default, that is again null. Should it execute? What I said that the ID should be unique. Okay, and I'm putting it as empty. So technically it should fail, right? No, no. But you can say to me that maybe one tray as one tray in that entire cabinet where the ID can be empty for one is possible. Okay, now let's put another one. New York, let's put it York. See, another tray came in with the null as the ID. But why it is allowed? Why the unique? Okay, this is interesting. This is really interesting. The concept of unique is, okay, what is the concept of unique? Unique says that a value cannot repeat. See properly. A value cannot repeat. If it repeats, it will throw an error. If repeats, it throw an error. Okay. But in this tray, where ID was there, name is there, address is there, this ID was kept empty. And when you compare something with the empty inside the cabinet that we have put so far, right? Cabinets. This is the cabinet. Can you compare an empty with a value? No, because it will means that it's empty. Because you cannot compare an empty with a value. You will always say it's empty, 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 empty. Does it violate this rule that a value cannot repeat itself? If value repeat, it fail. Is it repeating it again? No, because what result you are getting when you compare is empty. The value is not repeating. Okay, now it's gonna come here. Yes, empty one, right? Empty one. You have another record that I told you, right? Empty with the University of your York. With compare with the value 1, 2, 3. Okay, empty with compare with 1. Is it repeating? No. 2 not repeating. 3 repeat not repeating. Can empty is repeating with empty? No. Because empty is not value itself. It's like completely empty. Right? Can you say that empty is a value? No, it's empty. It doesn't have any value. So you cannot compare empty with any of these things, even empty itself. So you can simply write it does not violate this rule of unique. You can simply insert the data. Okay, I can keep it there. Right? Now to understand with an analogy, I will give you example of unique as a person in a country have two IDs. First one is your national ID. Second one is passport ID. Okay. So every person have a unique ID called national ID. It's by default by birth. But passport ID is something you get when you apply for passport. So there's a possibility that 10 or 20 people out of like 100 might not have applied for passport at early age and they don't have the passport. That means they don't have the national ID. Okay. But whosoever have it, it's a unique, right? So primary key is that passport. So whosoever have the ID, it has to have that unique ID. If not, it will be empty. Okay, so unique ID is not nothing but your passport ID. But sometimes we need this national ID. We need ID that can can identify any entity, any tray in that cabinet. And that's where we get the concept of primary key. And primary key is nothing but unique key plus not null. That means any record with a null is not allowed or empty tray is not allowed. Empty partition of that tray is not allowed. Okay. That means I need to convert this to a primary key. So let's alter this one. So firstly, I cannot simply go and create this one. I need to drop this one. So okay, so how to do it? We already learned it. We will drop constraint and then constraint in this one and we can drop it. Okay. Let's drop it. Now it won't check for the condition. But I want to add a primary key constraint, right? 4.2. Add primary key. Add constraint primary. Alter table, you need to go to the floor colleges, then you need to access the cabinet college, and then you need to make sure the tray that I'm going to slide in at any given point of time have the constraint, and constraint name is university primary ID, and you like primary key ID. Now if I run, let's command this to right now at time. Okay, I run it. What it says that I think I line number syntax error as values, right? Uh, where I made a mistake. New York, this one, right? Uh, let me run this now. Okay, Sometimes it happens. So see, 1, 2, 3, right? Now, primary key was like passport. That means whosoever have the ID is unique. Whosoever not have, it will be empty, but it will be allowed, right? Because they are the people, obviously. It's like a secondary ID. Now it's throw an error because here it is mandatory to have a unique ID. It cannot be empty. That's why this is not allowed. You need to put 4 here. Perfect. Now I can simply remove this one. So you understood the concept of primary key and secondary key. Primary key is the ID that cannot be null. It cannot be empty. It has to identify that tray, right? So when I apply this constraint, this condition, obviously it's not just about one trait. It is all about every trait, right? I cannot distinguish. So whosoever in the server is the outside the cabinet, everywhere you need to, you will get this one, right? Suppose before adding this one, I have already inserted the values. Okay, let me quickly get this thing. Okay, I have like, okay, it is running right now perfectly, right? This one. See here. Before even I make it a primary key, I'm adding a value 1 here. Okay, with this record. When I'm making primary key, okay, and then I'm trying to insert this one, it will fail. Okay, it violated, right? It failed. So let me put this one. And now I execute it passed because right now the value I'm adding this one, right? But what happened? You says like Nathan, you are right on this one, completely fine. But what happened before I make it insert? I have this two IDs already existing before I apply the primary key. Two trays are already inside this one. See again, college ID failed duplication. Where I'm going to remove this one. Let's remove this one just for in case you get confused. Okay, before adding the constant that is ID is a primary key, I had two records with the 1 1 as your values. Right now, make it like this one. I am emptying this, commenting. See, I got two records with 1 1 ID. Okay, so they are two different. Now see duplication. So when you add a constraint, anything on the tray level, it will apply throughout all the tray, no matter is it inside or the outside empty trays. Inside the cabinet that's already placed or outside the cabinet. You need to remember it apply on that tray cabinet that's already placed or outside the cabinet. You need to remember it apply on that trays. So now I can remove this one and I run this and I run this one. Okay, perfect. So this is done. Let's see what else. So we are done with primary key and the stuff. So constraint is done. What else? Create, drop, alter, everything is done. Insert, update, delete. Insert is already done. Update and delete, I need to tell you. And the drop. And this is your. Why didn't I start this one? 3, 4, 5:30. Dude, I think I already exceeded the time. 2, 2, 3, 3 to 4, 4 to 5, and 5 to 5:30. Yeah. Uh, I already exceeded, but I will quickly wrap this up. So I'm going to talk about already exceeded, but I will quickly wrap this up. So I'm going to talk about data type, and then I will talk about top and update and top. Okay. So let me quickly go into this one and let's start about insert is done. Now let's quickly do update and delete. 6 1 is update. Okay. Now let's update this one. I found that for ID 1 and 2, both have the same name, right? These are the different names. Okay. Right. Okay. So first one here, see for the ID one, that is primary key. That means if I use this ID in a tray, I can easily get this particular tray with all this information. I felt like, okay, UC is very short name. I want to make it complete in University of California. So what I can do, I can simply access this particular tray, pick it out, change, replace that object, the name of UAC with this one, right? How to do it? Simple. When you have to replace the object, you use the word update or update keyword. So update uh table name. So you need to go to the colleges floor and access the college as your cabinet, right? Then you need to set, like how we were setting not null and null, right? And then we were dropping not null and the thing. So when you need to set a value, you will use the keyword set. What you gonna set? Name that particular partition in that tray with the new object, University of California, California, right? But it goes to all the cabinet and started putting the name this one. How you will make sure that it only make the change to the cabinet with partition ID, because whatever query you run, it run one by one to all cabinet, all the trees, right? So why want to exchange? I want to change the object name for a tray where the partition ID has the value one, right? So you can write. So for this one, where you will use the keyword where. So where that tray had the partition ID with an object valued one, right? I will run now. See, now it becomes University of California. But you see how it changed from this to this, right? This is update. Right now, what you felt like, okay, I want to do one more thing. I want to add the address as well. Okay, on the same object or multiple object, you can also change. You can put multiple this exchange within the same uh statement. So you can put like with the comma separation, you can like address. You can put University of California Southern Beach. Okay, now you access all the tree one by one. You identified and take action of replacing name with University of California and address as University of California, California Southern Beach, where the partition in that tree have the object value one. Okay, we'll run it. See here, it changed for this one. If you don't put it in this way, if you don't put that condition that you make a change only for the tray which have the partition ID with the value 1, see, every name change because you haven't specified the condition. But now if you do this way, it's done. Okay. Now, seventh is that we want to learn is delete. For this one, you use the keyword delete, and then you will, how we are using set here, we use from. You need to delete from again, college's floor, that called cabinet college. And if you don't do anything here, again, what is that? It will take, it will access all the cabinet, inside the cabinet, all the tray, and it start throwing that all the information in the bin and throw that off. See nothing, right? But that's something I don't want. What I want to make sure that the value I'm dropping where the cabinet inside the tray, the partition ID have value one. No, so two. Okay, now two. This one, I want to delete this three because I felt like these two are the same records. So I felt like no, I want to keep only one record, and I want to drop UOSC Patrick for number three. Okay, so I do that. See, three is gone now. One, two, four. So that means we are good. So this is the delete option that we have. Okay, so what else? We are able to do manipulation. Okay. There's one thing that I always want you guys to know is about returning. So now what happened when I execute these three statements? I need to run select a statement to check the value, right? I was doing that. But there is one particular keyword that you can use it to get the values that you want to check whether it is updated or not. That is returning. If you write returning and then you write ID, name, address, so whichever the object it is affecting, it will return the new value. So now you deleted number three, it give me all these values, right? So it is good. Similarly, you can do it for here as well. You write returning. Now what you change the name from whatever the ID was there, ID1, right? And then you change it from this to this one. I want to keep a track and see the old ID and new ID. So you can use it through old suffix. So you will put old dot name, then you will comma, then the next corresponding column to this one, new dot name. So it will give you one column with the old name, then the new name, and then again old dot address, and then new dot address. If I run this one, you see, it gave me for ID1, it is changing UOC, University of Carolina, null to this value. Suppose I remove this one, right? How we remove it? Now it will change every name to this one. But which are the names and which are the address is changing? See, UOC become University of California, UOSC become University of California, this one. But that's something I don't want, right? What I want for the tray where the partition ID is 1, I want to change whatever the name it has to University of California, and whatever the address it has, it doesn't matter. Change it to University of California, Southern Beach, and that I can check using this one. Okay, same with this one. You can simply write returning star, and you can simply do this one. And if I run here, see, it returned, that means it's adding 4, the name, and this one, right? Suppose this one address is already taken default. So I was like, I don't want to access this one. It will automatically keep it the default value you place it. Default is empty, right? So it's simply running. Come now, right? So you can do this way. So returning is something that I genuinely love this one. I don't know why, but it is more interesting than any of this other. So I think with this we pretty much cover insert, update, delete. We covered the create, installation, this one. I think only data type is left. For data type, I will be very quick here. So I told you that whenever you are working in relation database management system, you create that schema, then cabinet, and for the cabinet you create that this tray, right? And inside the tray you define the partition is name and what kind of an object you can store. It is metal, it can be gold, it can be one. So this, what type of item? So here in the digital world it become data type. What kind of a data you're gonna store? So there are multiple data type. One is integer, then it can be float, that is real, or double precision, that's float 4 or float 8, or numeric with precision comma your scale, or decimal, again same precision comma scale, or you can go with the date or timestamp, or you can go with varchar or character. Okay, these are the data type. Let me explain one by one. Okay, so what integer does, it will take positive plus whole number. For example, it's always a 4 byte character. So 4 byte, I don't know how much it make because I forget. 2 to the power 248, I don't remember, dude. I don't remember. Anyways, it should be like a minus 100, minus 99, like this, 0, 1, 2, and so on. It's like a whole number, right? It's no, it's like an integer number. Okay, now float, what it does is a real or float 4. It store the decimal value like 456.167828, and double or float 8. You understood that it hold till 4 byte of character. It hold till 8 byte of character, like 2168 dot 1234 something. Now the caveat here is for real or float 4, it will round the seventh digit after decimal. Suppose your value is like 2, 3.1234567 and 8. It will round to this number. It become 2, 3.1234566, and it will round because 7 is your bigger number, right? It become 8. So you miss out the information if it's more than that. And for double precision, it goes to it store the information till 15 digit and it round to 16 digit. 6, then it's 7, it become 15 and 16. Okay, where it is useful when you are performing some experiment and you can afford to round till 6 or 15 digit because it won't create an issue, because the storage of this one and access of this information is faster. Okay, but if you want to store money, detail about the money, someone, will you be happy if somebody started rounding off your money one by one? Everyone, every time you made a transaction, no, you want exact money. That's where when you want to store exact decimal or something, you use the numeric data type. Okay, if you are not putting anything scalar this way, it will take any number depend on your system. But if you put a value of precision and scale, comma scale. So suppose you put numeric, precision is 8 and scale is 2. So what gonna happen? It will allow two digit on the right side and left side will be precision minus 2. Precision minus scale, that is age minus 2. That means 6. It can have 6 digit here. 2, 3, 4, 1, 2, 3, 4, 5, and this is 6. And similarly with numeric 6 comma 2 minus 2. So if it's minus 2, that means it will have nothing here. It will be empty. So dot nothing. That's why it's just an underscore. Okay. On the right side, I told you it will be 6 minus the precision, 6 minus 6, 8. So it's gonna be 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. But minus 2 is like it will round after this. Okay, so suppose it has value 1, 2, 4. So 4 is nothing, it will remain 4, it becomes 0, 0. Suppose it have 5, it will become 6, 0, 0. Suppose it has 9, it will become 0 and it will increase the value here, whatever it is. And I can give you an example here by running few things. So select, I want to convert like 1, 2, 3, okay, to numeric. Okay, so I want to convert like, uh, suppose how I want to convert. So minus minus will become plus. So I want to 1 and minus 2. Okay, and I execute this one. This one. It become 100, right? It become 100 here. So what is does the number on the right side is 0 because negative here. On the left side, 1 minus minus 2 is become plus 3. So the third one get round off. First, second, third. Till 2, it will be 0, 0. And the third one, this one, it will become round. Okay. Let's suppose it's 3, again 0, right? So 0, 0, 0, and everything will become 0. Okay. But if I make it 1, so what it does, it can have hold only two numbers. I am giving 3, so it's gonna throw an error. That's throw an error, right? Because number number of significant digits, significant. That means the number left side to the decimal should be precision minus a scale, and here it is 1 minus then minus 1, that is equals to 1 plus 1 because minus minus become plus, and that means only two digit allowed. But the problem is I'm trying to convert three digit into this one, so that's not right. That means either I have to change this to 2 or that 2. So now what happened, 2 minus 2 it becomes 3, right? It will fail. Okay, and now make it 2. So 2 minus minus plus 4, 1, 3. That means it will have 3 digit. Yes, indeed it has the 3 digit or less than that. And how many zeros will be there? Only one digit will be 0. It will 0 and it will convert 2 to the 1. Let's make it like 6. Let's see whether it convert 2 to 3 or not. It converted. So the very last one will be responsible for this one. So it's 6, right? So 6 will convert it to 0 and the next one will convert to 3. Perfect. After this one, we are good with, we are done with your integer, double date, and then varchar and the char. Varchar and char was a bit confusing for me, but let me explain you. Character and varchar. Okay, so when I define character as 5 and I define character as 5, what happened in a shop? For this particular character you can take 5 boxes, and for this one you can also 5 boxes. But how it does it, okay, suppose I wrote, for this one I want to store NITI, okay, NITI, okay, 4 digit, and suppose NIT net, okay, NIT, and here I also want to store NIT into this data type, or the tray for partition, suppose putting name, okay, I want to store the object name. One is N1, this is name 2. Here I'm putting the character 5, and here I'm putting varchar 5. So when I put the information, I go and take one tree and I want to put an object NIT, okay, NIT for this one, name 1 and then name 2. Okay, so how it goes. So for this one character 5, it goes to this market and get 5 boxes. One, two, three, four, five. Okay, 5 boxes, and then place object and IT, and this is empty, and then this it plays in the tray. Okay, this is character 5. So one, two, three, four, five, and first three I have the value and IT. Worker, what it does when he knows that three character, it goes to this shopkeeper. He knows his limit is 5. He have that ticket of 5. He worker, he know he gonna place 3, so he will get only 3 tickets. 3 boxes, one, two, three, and put an I. Okay. So now, if you ask someone what is the size it use 5. How many size it use 3? How many length of the character it has? It is how many, means how many is filled is 3. Is 3. You see the difference? Okay, that's the one. Suppose I put it like, rather than NIT, I put empty string than NIT. Now goes back to here. It take 5 boxes again. Three, four, five. It put empty here, then N, then I, and then T. And then it put again in the next tray as empty. Then N, then I, then T, and then this empty value. Okay, and this is empty. For varchar, what it does is to add this value, and it store uh and I. I don't think it is stored this empty value. So this length become like one, two, three, four, 4 digits, like 4, and it become again 3, and we will check it quickly because that's how you should be learning. Okay, now let's select. I put select. Okay, I put NIT, right, like, and comma. Okay, NIT, and I want to store is as character of 5. Okay, and here I want to convert it to character varchar of 5. Right. Now run it. Okay, both are saving it. But what I want from this one, I want the length, right? So let's put it this one. So I want character length. Is it right or failed? And no function matches this argument, casting, and then how to do it? I need to check. Let me ask it. Which one is PostgreSQL? Sometimes you can simply use the things that make your life easier. I think I need to cloud. I don't want to waste my write on the cloud. and it will give me the answer. That's how you should be using AI. Once you read through the proper documentation, you will then simply ask for the better understanding, and I will be like, let's see. In PostgreSQL character, pad with a space. This one with trailing. This character length. Okay. Uh, so it's a character length. GST character length. LNG character length. Okay, spell mistake. So it came 3, right? And again, I need to check for this one for varchar, right? Now execute. Okay, both have this 3 3, right? We are good on this one. Now I want to run it against, and but but at the moment I don't want to put anything. I want to put that space here, space, space, and space. Now I want to execute this one. Now it become 4 4. That means they are taking this one. But what happen if I put out the this is the one. Okay. But right now I want to put trailing here through four. This 4. What do you think what gonna happen? See here now. Here. If I run this one, BP character, BP character. See 3 is 4 4, but here it become 4 and 5. You see, the length of char still remain 4 despite the fact I put this up. But here it considered this properly and gave me the result as 5. 1, 2, 3, 4, 5. Here 4. Here is 5. Right? So what it means for the trailing, the empty value of this one is this space or white space on the right side of the text, character don't consider it as the length, but varchar consider it. Okay, so varchar consider both the starting and the ending spaces, but char consider only the starting one, not the trailing one, and that's tricky. Mm. Perfect. So I think with this we are pretty much done for char varchar. Okay. Okay, padding right. So only 5 seconds. So I want to write like here. So Postgres pads with a space to a specific length. You have a length trim. So see, it trimmed the trailing spaces, correct? And it will trim the trailing spaces and get the value for you. I want to understand if I have character 5 and put the value as an ID. Does it take all the 5 character space and put white space in the remaining 2, and how where can react? Right? Yes. So I want to understand. Yes, exactly. So see, length is number of number of boxes you are using to store the characters, number of character storage. Okay. So when varchar is always use all you always have the access to the port, but varchar it will only have the access to the to the boxes you want to use, and that's the one. So if you look NIT, it will have all five character use. It will use only three character from this one. So it's heavily space consume data type. Hello 5 5, hi 5 5, and that padding, always padding or with the spaces is a never pad. Maximum length 5 up to 5, exactly 5, and it is up to 5. There's a difference. The maximum length a character goes is always 5, but here it is 5. So so fix. Okay, that I want to ask. If char has maximum length of, okay, it can have maximum length, but maximum length of 5, but when I run char length ng ht gst, it gives me only 3 4 niv, but it type in modern application where char or plain text is preferred over character since it's a fixed padding. Okay. Uh, okay, so it always have it always occupied the complete space. It's just the length it gives the number of storage or the byte used. There's a difference here. The space it occupied is always the maximum length, but the space used is the character length is the value. So it always trim off this one. Varchar is the same, so it have the exact number and this one. Perfect. It makes sense to me now. I think with this we can wrap this up for entire week. We have already learned everything in thorough thing, and I'm going to store this value. Ah, dude, it is so much I learned today. It's amazing. It's amazing, and I hope you guys also learn a lot today. I will save it. So SQL week one revision. This is done. And do you have any questions so far? If somebody joined by God grace to my, okay, nobody. So 118 minutes. So my plan was three session of 30 minutes, 30, 60, 90. But it exceeded to 120, 90, and 30 minutes. That means I get one more session utilized. Or okay, that's not the right thing. But with this, I will wrap today's video. I learn a lot. And if you like my videos on this one, please make sure you subscribe the channel because it keep me motivated to keep on making more videos and learn more